guys, so today we're going to look at some three variable systems. So this is going to be a little bit different than what we did back in Algebra 1, but still going to use some of the same kind of building blocks. So earlier back in Algebra 1 you had systems that looked something like this. And what you had to do is basically that was the equation of two lines, and you were trying to find the intersection of those two lines, and that's what that system was. Well, now that we're getting into these three variables, we're going to introduce another component, which means we're really not looking at the intersection of lines, we're actually looking at the intersection of planes. So this first one shows you an example of what that will look like, where you've got three planes, and they're all intersecting at that one point. So that one point is going to have an x, y, and z coordinate. Because again, like let's take that green one. I can move that green plane this way. I can move that green plane this way. I can also move that green plane up and down. So all of those components can change where that intersection is. So this would be an example of what it would look like if you had one solution. The next one, that's another way for those planes to intersect, but if you notice this time they don't intersect at a point, they actually intersect at a line. And because that line has more than one point where that can meet, there is actually an infinite number of solutions here. Because any point on that line can be an intersection of that. All right, then looking at this next one, obviously those have no solution because they do not intersect. And looking at the last one, even though these intersect, this also is no solution, because there's not one place where all three of those planes are intersecting. So this one's also no solution. So you'll notice this, it's not quite as obvious as it was in Algebra 1, like where you had parallel lines, they weren't going to meet. If you had the same line, then it was going to have infinite solutions. So a couple different cases here for no solution or infinite solutions. So algebraically, what's going to happen here when you're solving these, if you have an infinite number of solutions, you're going to get something that comes up where you get some sort of true statement. Like you're solving this out and you end up with 7 equals 7 or something like that. If whatever statement you end up with is true, then that's something that always happens, that is an infinite number of solutions. If you get something that's not true, that doesn't happen, something like 1 equals 6 or 2 equals 0, since those are things that are not true, don't happen, that's going to be a case where you have no solution. Alright, so there are multiple methods we can use to solve these. The first one we're going to look at is substitution. Substitution is probably the easiest method if one of your systems has only one variable, or if you just have less total variables in your system, it would be easier to use substitution. So very similar to what we did with two variable systems, we're going to solve for one of my variables. So I'm going to go ahead and solve this first one for y. So I'm going to do 3y equals 6z minus 6. So y is going to be 2z minus 2. Once I've solved for y, then what I can do is I can take that, I can plug it back in to my other two equations. So I'm going to take that and plug it back into the second equation. So x minus 2z minus 2 plus 4z equals 10. So that gives me x minus 2z plus 2 plus 4z, which gives me x plus 2z equals 8. All right, now I'm going to take that same y equals, I'm also going to substitute it into the bottom equation. So 2x plus 2y minus 2z minus 2, minus z, go. Okay, then substitute or simplify from here. So 2x plus 4z minus 4 minus z. So that gives me 2x plus 3z equals 16. So what I'm going to do then is I'm going to take those two equations that I ended up with, and I'm going to write a new system with those two equations. And then I'm going to solve that system the same way I've solved my systems back in Algebra 1. So I can use either substitution or elimination. I'm going to go ahead and do substitution just because we were doing substitution already. I'm going to plug that in. All right, so that gives me so I end up with negative z equals 0, which means that z is equal to 0. Once I have one variable, I can take that and I can plug it back into that 2 by 2 system to get another variable. So I plug in 0, that tells me that x is going to equal 8. And once I have two variables, I can take those and plug them back into my original to get my missing third variable. So in this case, I would get 3y equals negative 6, so y equals negative 2. All right, so let's go ahead and try another one. Let's go ahead and try b. So again, we're going to solve for one variable in one of those equations. So in this case, let's go ahead and let's solve for y in the first equation. So I'm going to get that y equals negative 4x plus z plus 2. So I'm going to take that, plug it into the next equation. So 4x plus negative 4x plus z plus 2 plus z. And then I can simplify this, and I'm going to end up with 2z equals 0. So z equals 0. Now there's two places I could go from here. One place, if you think that z is equal to 0, if I were to go and plug that in, you would notice that what you have left, 4x plus y equals 2, and 4x plus y equals 2, those are the exact same, which means that they're going to have infinite number of solutions. Another way that you could have gotten there, let's say instead you continued and you plugged that y into that bottom equation. So if I did 12x plus 3 times y, and if I solved this, you'd notice 12x minus 12x, z and z. And if I wrote the original question down right, you'd notice all that's left is 6 on one side and 6 on the other. And since that's a thing that's always true, again, that's another way of seeing that we have infinite solutions. So if either that 2 by 2 system ends up to where you can tell that that's infinite, or if you end up with something like this when you're solving an algebraic, that's a way to know there's going to be an infinite number of solutions to the system. All right, so another way to solve this is by elimination. So when we're solving by elimination, what we're going to do is we're going to start by picking two equations, and we're going to eliminate one of those variables. So it doesn't matter which ones we do. I'm going to go ahead and do 1 and 2, and I'm going to solve 1 and 2. I'm going to eliminate z. So in order to do that, I can keep the first equation the same. And then the second equation, in order to eliminate z, I need to multiply everything by 2. So 4x plus 6y minus 2z equals 8. So now, I end up with that equation. So now I need to pick another set of two equations, and I need to eliminate the same variable that I eliminated in this equation. So it doesn't matter which set I do. I can do 1 and 3, or I can do 2 and 3, but I need to make sure that I eliminate z. So I'm going to go ahead and do 2 and 3. In order to do that, I'm going to multiply that second equation by negative 3. So that becomes negative 6x minus 9y plus 3z equals negative 12. So then I can add those together, and I get my second equation. So now, out of this system, I'm left with two equations and two variables, and I need to solve this system. Again, you can use either elimination or substitution at this point. I'm going to go ahead and do elimination because that's what we've been doing. So I'm going to multiply that top equation. I'm going to multiply everything by 7. before I get any further, I'm going to write the whole problem again. That was 11, that was 19, which means that this is 19. So then I've got negative 13 times 7, which is going to give me a negative 91. So now I can add those together. I get a negative 18y. It's going to be a negative 72. So y is going to equal 4. Once I know one variable, I'm going to take it, plug it back into one of those two equations. So if I do negative x minus 16 equals negative 13, so negative x equals 3, so x equals negative 3. So now that I have two variables, again, I can take both of them and plug it into any of these equations from the original one. So let's go ahead and do the first one. So 3 times negative 3 plus 4 times 4 plus 2z equals 11. So that's going to be negative 9 plus 16. So 2z equals 4, so z is equal to 2. Alright, so if you feel pretty comfortable, go ahead and pause the video and go ahead and try these next two either by substitution or by elimination. Alright, so on A, I'm going to do elimination, and I'm going to go ahead and eliminate for y because it's already really done for me in those first two. So I'm going to start by adding those top two together. So that's the result of adding 1 and 2 to eliminate y. So then I'm going to move on and I'm going to try and eliminate y, and I'm going to go ahead and do 2 and 3. So that means I need to multiply that second equation by negative 6. So I'm going to rewrite it. And then I can go ahead and eliminate that y. And now I've got my new system. So I'm going to rewrite my new system. Here's 5x minus 13z equals 31. And again, I'm going to go ahead and do elimination here as well, because all I would have to do then is multiply by 3. So 15. 39, 93. Those x's will cancel. So then I'm going to have a negative 72z and 144. So I'm going to get that z is negative 2. I'm going to take z, plug it back into one of those two original equations. So let's say I plug it into that red equation, so negative 15x minus 33 times negative 2. So there's my x. Take both of them, plug it back into any of these top three equations. Let's go ahead and do the bottom one. So 2 times 1 plus y plus 3 times negative 2. I get that y equals 4. All right, looking at b, so I'm going to go ahead and try b by elimination. So I'm going to multiply that top equation, multiply everything by negative 5, and you'll notice if I do that, everything is going to cancel out on the left side. So I would be left with 0 equals negative 7. Well, that's never going to happen, which means this is a case where there are no solutions. So again, if you get some false statement algebraically, that's saying it's no solutions. If you get some sort of a true statement, that's telling you it's all solutions or infinite solutions. All right, so the last thing we're just going to look at is a couple of word problems. We're just going to set these up. We're not going to work through the whole thing. So this first one has a photo album, has 80 pictures. It's either a square, a rectangle, or a circle. Then it gets some information about how they relate to each other, and then it wants to know how many of each type of picture is in the photo album. So we've got 3 variables here. We've got squares, we've got rectangles, and we've got circles. So since we have 3 variables, we have to have 3 equations in order to set up this system. Well, we know the total here is going to add up to 80. Then we know there's 12 times as many rectangles as there are circles. So what I would do then is I would take my circles. If I multiply the circles by 12, that's going to give me the number of rectangles. When it comes to checking this, I think what's easiest is if you pick like a really simple value. Like if I say that there's 1 circle, well, if I plug that in, then I would get 12 rectangles. And I need to see if that makes sense. I said there's 12 times as many rectangles as circles, so yes, that does fit. That makes that statement true. All right, next one, there are 10 more squares than circles. So again, very similar. So if I take my squares are going to be, if I have my circles, plus 10. So if I had 1 circle and then I added 10 to it, then I would have 11 squares, and there should be 10 more, so that works out. So then from here, if you want to find out each type, then you can just solve that equation. All right, then the last one. So we're going to write a system to solve this triangle. So some information it tells you that angle B is 5 of angle A minus angle C. It tells you that C is angle A plus angle B. Then the only other piece of information we need, we know this is angle A, this is angle B, and this is angle C. We know that all of those have to add up to 180. And that gives us enough information to solve our system. All right, so that's it for systems for today. So again, you can either use elimination or substitution. Basically, your goal is to get it down to 2 equations with 2 variables and then to solve that one.